Hi, welcome back to my class in Differential Calculus or Calculus 1. For today, we will take more examples for obtaining the derivatives of functions using the definition of derivative. According to the definition of derivative, if the given function y equals f of x, for the given function y equals f of x, the derivative of this function y equals f of x denoted by y prime is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. For using this definition of derivative of the function y equals f of x, we find the derivative of y with respect to x. This notation is the same as this notation y prime. They both denote the derivative of the function y, a function of the independent variable x. For the following examples, we find the derivative of y with respect to x. If in number 1, the function y is equal to 3x squared minus 2x plus 5. In number 2, y is equal to the root of x plus 7. We start with number 1, comparing the given function in number 1 with our function notation. We have f of x equals 3x minus 2x plus 5. We write f of x equals 3x squared minus 2x plus 5. In the definition of derivative using limit, we need f of x. In number 1, f of x equals 3x squared minus 2x plus 5. And from f of x, we obtain f of x plus delta x. F of x plus delta x. And we obtain the value of the function at x equals delta x by replacing every x in f of x with x plus delta x. Replace every x in the function f of x with x plus delta x. Hence, f of x plus delta x equals 3 multiplied by the square of x. X is x plus delta x. X plus delta x is square minus 2 multiplied by x. X is x plus delta x minus 2 times x plus delta x plus the constant 5. And we simplify the right-hand side. For the square of x plus delta x, we apply the special product rule for the square of a sum. And that special product rule says that the square of a sum is equal to the square of the first term. First, we have 3 as numerical coefficient. 3 by special product rule for the square of a sum. The square of x plus delta x equals the square of the first term x, or x squared, plus twice or 2 times the product of the first term of the 2 terms in the sum, twice the product of x and delta x. You write x times delta x plus the square of the second term, the square of delta x. We write plus delta x squared. In the second term, we distribute negative 2 over addition. Negative 2 multiplied by x is negative 2x. Negative 2 multiplied by positive delta x is negative 2 delta x. and the constant term, plus 5. We simplify further the first term by applying distributive property of multiplication over addition. We multiply each term of this trinomial by positive 3. We get 3 multiplied by x squared, this 3x squared. And 3 multiplied by positive 2x, delta x is 6. X delta x. And 3 multiplied by delta x squared is 3. Delta x is squared. The last 3 terms are the same. We write minus 2x. Minus 2 delta x. And plus 5. And we combine like terms. If there are like terms in this, but there are no like terms, now we have f of x equals 3x squared minus 2x plus 5. And we have f of x plus delta x. Now we get the difference between f of x plus delta x minus f of x. We write f of x plus delta x minus f of x equals, we substitute the value of f of x plus delta x, which is 3x squared plus 6x delta x. 6x multiplied by delta x plus 3 delta x squared minus 2x minus 2 delta x and plus 5 minus f of x minus, since f of x has 3 terms, we write these 3 terms in open close parentheses. We take the negative of the 3 terms of 3x squared minus 2x plus 5. And we simplify 3x squared plus 6x delta x plus 3 delta x squared minus 2x minus 2 delta x plus 5. We multiply each term of this trinomial by negative 1. Negative 1 multiplied by positive 3x squared is negative minus 3x squared. Negative multiplied by negative 2x is positive 2x. And negative multiplied by positive 5 is negative 5. Now we combine like terms, or we cancel terms that can be cancelled, those terms that will add up to 0. Like 5 minus 5 is 0. And we have positive 3x squared minus 3x squared is 0. We have negative 2x and positive 2x will add up to 0. Hence we are left with 6x delta x. 6x delta x plus 3 delta x squared and minus 2 delta x. And by inspection of these 3 terms, you can see that each term has delta x, and the lowest exponent of delta x is 1. Therefore, we factor out delta x to the power 1 from each term. We factor out the common factor. Common factor for each term is delta x, or the three terms have a common factor of delta x. So we write delta x, and we find the other factor by dividing each term by the common factor delta x. 6x delta x divided by delta x is 6x. 3 delta x squared divided by delta x is 3 delta x. And the last term, negative 2 delta x divided by delta x is negative 2. We now find the derivative of the given function y, denoted by y prime using limit. This definition of derivative using limit. So derivative of y denoted by y prime equals the limit of the difference between f of x plus delta x and f of x, which is equal to delta x multiplied by 6x multiplied by 6x plus 3 delta x minus 2 all over delta x as delta x approaches 0. By inspection of this, you see that there is delta x in the numerator and delta x in the denominator, and they will cancel out because delta x divided by delta x equals 1. And derivative of y prime is now equal to the limit of 6x plus 3 delta x minus 2. And we get the limit of this as delta x approaches 0 by replacing delta x with 0. That is by using a limit theorem. Hence, the limit of 6x plus 3 delta x minus 2 as delta x approaches 0 equals 6x plus 3. Replace delta x with 0. We multiply by 0 minus 2. Which simplifies to 6x. 3 by 0 is 0 minus 2 is minus 2. And this is the derivative of 3x squared minus 2x plus 5. Its derivative is 6x minus 2. In the second example, our function now is a radical function equal to the root of x plus 7. The square root of x plus 7. And from f of x, we get the function value f of x plus delta x. F of x plus delta x. We get this value f of x plus delta x from f of x by replacing every x with x plus delta x. We replace x with x plus delta x, we get f of x plus delta x equals, at the right hand side of f of x, we replace x with x plus delta x. Square root of x plus delta x plus 7. And we substitute these two in the definition of derivative. The derivative now of y with respect to x, derivative of y with respect to x is equal to the limit of f of x, the limit of f of x plus delta x, which is equal to the root of x plus delta x plus 7 minus f of x equals to square root of x plus 7 minus the square root of x plus 7 all over delta x. And we find the limit of this quotient as delta x approaches 0. Now to simplify this expression, we will rationalize the numerator. And to rationalize the numerator means to remove the radical signs from the numerator. And we will do that by multiplying numerator and denominator by square root of x plus delta x plus 7 plus square root of x plus 7. Before we get the limit of this rational expression, we remove the radical signs from the numerator, and we do that by rationalizing the numerator. And to rationalize the numerator, we multiply the numerator and denominator by square root of x plus delta x plus 7. We multiply the numerator by square root of x plus delta x plus 7 plus the square root of x plus 7 plus the square root of x plus 7. And we multiply the denominator also by the same expression, the sum of the square root of x plus delta x plus 7 plus the square root of x plus 7. To the numerator, we apply the special product rule for the product of a sum and difference. Notice that the first terms are the same, the second terms are the same, and the two terms between this binomial and this binomial differ only in the signs, the operation between the two terms in the two binomials. So we apply the special product rule for the square of a sum and difference, which says that the product of a sum or difference is equal to the square of the first term, square root of x plus delta x plus 7 squared, minus the square of the second term, the common second term, square root of x plus 7 all over delta x multiplied by this sum or binomial, the square root of x plus delta x plus 7 plus the square root of x plus 7. And we take the limit of that as delta x approaches 0. To the numerator, for the square of the root of this x plus delta x plus 7, and for the square of the root of x plus 7, we apply the property of radical that says the square root of x to the power 2. The square root of x simplifies to x. So the first term simplifies to x plus delta x plus 7, x plus delta x plus 7 minus, applying this property of radical, the square of the square root of x plus 7 is, since the radicand has two terms, we write it in open close parentheses and we take its negative. It's the negative of the sum of x plus 7. And we write x plus 7 in open close parentheses all over delta x times the root of x plus delta x plus 7 plus the root of x plus 7 and we get the limit of this as delta x approaches 0. And that's the derivative of y with respect to x. We simplify the numerator. We have x plus delta x plus 7 and multiply x plus 7, multiply each term of this binomial by negative 1. Negative multiplied by positive x is negative x. Negative by positive 7 is negative 7. All over delta x multiplied by square root of x plus delta x plus 7 plus 7 plus the root of x plus 7 and we get the limit of that as delta x approaches 0. Now cancel what can be cancelled from the numerator. You look for the terms that will add up to 0 and cancel them. Like positive 7 minus 7, they will add up to 0. So we cancel positive 7 and negative 7. And positive x and minus x, they will add up to 0. So we cancel x and negative x. And we are left with delta x in the numerator. Delta x all over the denominator delta x multiplied by the root of x plus delta x plus 7 plus the root of x plus 7 x plus 7 and we get the limit of that as delta x approaches 0. But you can see from here that there is delta x and delta x in the numerator and denominator, and their quotient is 1. Delta x divided by delta x is 1. So what is left if we cancel out delta x from the numerator and delta x in the denominator will be 1 in the numerator. Hence the derivative of y with respect to x we write the derivative of y with respect to x is equal to the limit of 1, numerator now is 1. The limit of 1 over delta x will cancel out, and we have the sum in the denominator is square root of x plus delta x plus 7. Square root of x plus delta x plus 7 plus the square root of x plus 7. And we get the limit of this as delta x approaches 0. Derivative now of y with respect to x equals, we find the limit of 1 over square root of x plus delta x plus 7 plus square root of x plus 7 by replacing delta x with 0, or we substitute 0 for delta x by using a limit theorem. Hence, the limit of this expression is 1 over square root of x. Replace delta x with 0 plus 0 plus 7 plus the square root of x plus 7 and we simplify. Numerator is 1 over x plus 0 plus 7 is x plus 7, square root of x plus 7 plus square root of x plus 7. The denominators, the two terms in the denominators are similar terms. Square root of x plus 7 is square root of x plus 7. And their numerical coefficients are 1. So we can combine the like terms in the denominators by adding first their numerical coefficients. 1 here plus 1 here is 2. Numerator is still 1. 1 over 2, and their common literal coefficient is the square root of 7. Square root, common literal coefficient is the square root of x plus 7. And this is the derivative, the required derivative of y with respect to x. The given function is, the given function y equals square root of x plus 7. Its derivative with respect to x is 1 over 2 multiplied by the square root of x plus 7. For your exercise, please try the following. Using definition, find y prime. The instruction says that you find the derivative of y with respect to the independent variable x using the definition of derivative of function. That is by using limits. In number 1, the given function y equals 7 plus 2x minus 8x squared. In number 2, the given function y equals the root of 3 minus x. Now, it's almost always lengthy to find. It's a lengthy process to find the derivative of functions using the definition of derivative of function or using limits. But we have differentiation theorems or theorems for finding the derivatives of functions, and we will apply these theorems to find the derivative of functions to simplify the process of differentiation. As we said earlier, differentiation is the process of obtaining the derivative of function. The first theorem says if the function y is equal to x to the power n, then the derivative of y, denoted by y prime, equals n multiplied by x to the power n minus 1. The exponent n of x is made as the coefficient of the derivative of x to the n, and 1 is subtracted from the exponent of x. In number 2, we have the given function is, the given function y equals k times a function. Then this theorem says the derivative of y, a function which is a product of a constant and a function, is equal to the constant times f prime of x. F prime of x is the derivative of the function f of x. Thus, the second theorem says the derivative of a constant times a function is equal to the constant times the derivative of the function. Number 3, the third theorem, the function y is equal to the sum or difference of two functions, denoted by f of x and g of x. If y is equal to the sum or difference of two functions, then y prime, the derivative of y, is equal to the sum or difference of the derivative of f, the first function, plus or minus the derivative g prime of x, derivative of the second function g of x. The third theorem says that the derivative of a sum or difference of two functions is equal to the sum or difference of the derivatives of the two functions. We now apply these theorems, the first three theorems on differentiation, to find the derivative of the given function. Examples: find y prime. That is, we will now find the derivative of y with respect to x using these theorems on finding derivatives, or theorems on differentiation. And in number 1, the given function y equals x to the 10. If you compare this with the first theorem 1 on differentiation, the exponent n of x is 10. N is 10. And applying the first theorem on differentiation, derivative y prime is equal to n. N is 10, the exponent of x, multiply by x to the power n minus 1. And n is 10. 10 is the exponent of x. Always subtract minus 1. And y prime is equal to 10 multiplied by x to the power 10 minus 1 is 9. Hence, the derivative of the function y equals x to the power 10 is 10 multiplied by x to the power 9. And we have employed the first theorem on differentiation. This theorem 1 can be proven using the definition of derivative, that is, by using limit where the function f of x is x to the power n. If you want to try to prove that the derivative of x to the n is n times x to the n minus 1. Consider number 2. In number 2, the given function y equals the square of 3x minus 5. The derivative of this function can be obtained in using more than one method, but since we have not taken the other differentiation theorems and the chain rule for differentiation, we will apply the first theorem for differentiation. And to apply the first theorem, we expand 3x minus 5 is squared. That is, we get the square of the difference of 3x minus 5 by applying the special product rule for the square of a difference. So we rewrite y as, by special product rule for the square of a difference, the square of a difference is equal to the square of the first term. First term is 3x, square it. 3x is squared. Minus, for the square of the difference, the second term is negative. Negative twice the product, or negative 2 times the product of the first and the second terms. 2 times 3x times 5. And the last term is positive, plus the square of the second term, the square of 5. We simplify the right hand side. By property of exponent, the square of 3x is equal to the square of 3 multiplied by the square of x. And the square of 3 is 9. 9x squared. Negative 2 by positive 3 is negative 6. Negative 6 by 5 is negative 30. Negative 30x plus the square of 5 is not 10. 5 square means you multiply 5 by itself 2 times. That is 5 square equals 5 by 5, which is equal to 25. So we get the derivative of this function, which is a trinomial. And derivative of y is denoted by y prime. By the second theorem on differentiation, the derivative of a constant times a function is equal to the constant times derivative of the function. We apply that second theorem for differentiation to get the derivative of the first term, 9x squared. The constant is 9, the function is x squared. Derivative of 9x squared equals the constant 9 times the derivative of x squared. To get the derivative of x squared, we apply the first theorem for differentiation. The derivative of y equals x to the n, which is given by n times x to the power n minus 1. Again, to get the derivative of x squared, we apply this theorem 1 for the derivative of x to the n, which is given by n times x to the n minus 1, where n here is 2 in this example. So derivative of x squared is 2 multiplied by x to the power n minus 1. And here is 2 minus 1, 1. Again, we apply the second theorem for differentiation. Derivative of a constant times derivative of a constant times a function is equal to the constant negative 30 times derivative of x. Here the exponent of x is 1. But if the exponent is 1, we omit the exponent 1, and without the exponent, it's understood that the exponent of x is 1. But we write 1 to identify the exponent n. In theorem 1, n now is 1. Hence, derivative of x to the 1 is n. N is 1. Multiplied by x raised to n minus 1. N is 1 in this second term. So the exponent of x in the derivative is 1. N is 1 minus 1, 0. The last term, 25, is a constant term. But if you want to apply the limit, the theorems for differentiation, you can write 25 as 25 multiplied by x to the power 0. Since x to the power 0 is 1, as long as the base x is not 0. For 25 multiplied by x to the power 0, we applied the second theorem for differentiation for the derivative of a constant times a function. And according to that theorem, the derivative of a constant times the function is equal to the constant 25 times the derivative of x to the power 0. And here, the exponent n is 0. Hence, derivative of x to the 0 is n0. Multiplied by x to the n minus 1, where n is 0. 0 minus 1 is negative 1. And we simplify each term. Y prime now is equal to 9 multiplied by 2 is 18. X to the power 1, we simply write as x. Here, x to the power 0 is 1, as long as the base x is not 0. X to the power 0 is 1, multiplied by 1 is 1. Multiplied by negative 30 is negative 30. And here, 0 times x to the negative 1 is 0. 0 times 25 is 0. So the last term is 0, which means that the derivative of a constant, of any constant, is 0. Derivative of any constant is 0. That is actually one of the theorems for differentiation. If the function y is equal to a constant k, then y prime derivative, then derivative of y is 0. If the function is a constant function, that is y equals k, then derivative of y is 0. Derivative of the constant k is 0. Just remember that derivative of any constant is 0, such as derivative of 25 is 0. Hence, the derivative of the square of 3x minus 5 is 18x minus 30. We will have more examples for applying the theorems for differentiation in the next lesson. If you have question about the lesson today, you ask your question in the comments below. But do not forget to subscribe to my YouTube channel, Art Calison. Thank you.